have going on here is the Adafruit Trinket M0. It's got a few things going for it. It is extremely tiny, as you can see, in relation to my hand. In fact, let's figure out just how tiny it is. We got this. It's like maybe 17, 16 millimeters across. And then like counting the little bit of USB, it's about 28 millimeters long, and it's just a couple millimeters high. The tallest thing on here is the USB micro connection. It's extremely small! Did I mention that? And okay, so it's got a little dot star LED on here. This is not a neopixel. It's a very small APA 102, aka what Adafruit sells as dot stars, and those are the same things that are actually on the Christmas tree that we got from Particle and looked at last week. So check that video out if you want to know more about these. There's some sweet things about this thing. The processor is upgraded from an Atmel regular Atmega chip to a SAMD chip, which means that it has much more processing power, and that's reflected in the name. So it's got more smarts than usual. It should be able to handle more that you're throwing at it. As I mentioned, the dot star pixel, which you can see is cycling through colors here, and we'll look at the code in just a second to see why it's doing that and how. It also works as a native USB keyboard. It's got this cool flat back surface so you can mount it to other stuff pretty easily if you want to make something, like another PCB to mount it to or something. And these guys are very low cost. I'm starting talking about the Trinket, but we also have the Gemma M0 over here, and they're both amazing. I actually like the Gemma a little bit more for a few different reasons, unless your consideration is size. As you can see, the Gemma is just a bit bigger. It's 28 / about 30 millimeters across, and then of course you have to deal with like the bending of the wire and stuff. But yeah, these also have touch built-in, capacitive touch sensing. So if I touch the pins over here, you can see the little red LED come on. And actually it's a lot easier to see this with the Gemma. Push the D0 pin, and that little L LED comes on. And they've included example code for this. Okay. I'm going to teach you how to look at the feedback from this in the terminal as well, because I didn't find a great guide for it, but I happen to know some things, so I can be your guide. Another thing that I love, oh yeah, so this thing goes for $9. $9, and this one goes for 10! Not with the battery included, that's my battery, but you can get them pretty cheaply. Yeah, $10 for this one, probably due to a few extra features we will talk about in a second, and $9 for this one. Neither of them has any wireless, but who cares? Most of your wearable tech projects don't need wireless, honestly. Honestly, they don't. And another thing that I really love about these, actually, is that just like the Circuit Playground Express, which we took a look at a while ago, they have this beautiful matte black finish, and that is just my favorite finish for PCBs, so I got really excited about it. And I mean, you know, usually you're not expecting people to actually see the PCB inside of your project, the microcontroller, but if you do, you won't be embarrassed. Who wants to be embarrassed with an old-fashioned, shiny, gross, vomit green PCB? I actually kind of like the old look. Even bare fiberglass is still really nice, and you know, if you mill your own out of copper clad board, that's beautiful, but this, to me, this is the PCB equivalent of a little black dress. It's just so good. Yeah, and you can program these guys in CircuitPython. They come with code loaded, and the way that you see that is that you plug it into your computer, and it shows up as a little USB drive, and then you edit the Python files in order to change the code, and then you save it, and you're done. There's no compiling and uploading and stuff. It's all already on the board. You just eject the thing from your computer after saving the code and unplug it, and then you're good to go. It's amazing. It's just so solid. I love it. Instant feedback. So, what makes these two different? Obviously the size. The Gemma is a little bit bigger, but that's because it packs some extra things. For one thing, it's got this lithium, well, you can connect, I guess, whatever type of battery you want, but it has this JST battery connector so that you can plug a battery in. That means that if I unplug this, which I won't do right now because I've got it hooked up to my computer all nice and happy, if you were to unplug it, it just stays on. Nothing happens. And it also has an on-off switch, so you can just turn it on and off, which I love for wearable projects because I hate plugging and unplugging batteries all the time. Uh, an on-off switch is so simple, and it seems like such a weird thing to ask, but honestly, that makes my life so much better with portable projects and bike lights and stuff like that. Anything that you can just turn on and off, it's a simple request. Um, oh yeah, so the Gemma has a battery connector for the JSU battery, but you can also get a backpack for the Trinket that will allow you to. It includes like a charging circuit, so you can charge a rechargeable battery that you plug in. That does cost about $5, so at that point, you know, any cost savings you got, like $1 savings, $5 backpack thing, it's basically a wash, but it might still be a little bit smaller depending on the, you know, shape of your project and how you want it to look. This one also, the Gemma also is an upgrade of the Gemma board, which is designed to be put in e-textiles or wearable tech. So it has these sewable little tabs here, which also can be used with alligator clips very easily, but I like them for sewing with conductive thread. I just got a switch on it. I think I covered everything. Okay. So let's take a look at the actual code running on these guys, because I have projects that I need to get underway, so I've already taken a look at most of this stuff, and that means we're going to go into very brief infinity mode, and then, yeah, it'll get better, I promise. Okay, so, alright, so, ooh, I have the wrong thing up here. Woo, there we go. So here is the code that is on the Gemma, and what does it include? We've got the time library, we've got touch, we've got stuff like that. Okay. Basically, okay, you import a bunch of libraries here, right? And oh, you know what? This is actually the CircuitPunk jacket by Tony DiCola. That's why. Okay, here's my other window with all the stuff that's okay. So Tony DiCola actually is this engineer with Adafruit who's really cool and built a CircuitPunk jacket that includes some of these boards. I think he used the Gemma M0, and he shared his code with me because I got really excited about the Gemma on Instagram, and you can look around for the link to that. He sent me a Dropbox link to his code, and I guess I'll see if he's cool with sharing that, but I assume so. He posted it on my profile. Alright, anyway, so this is the default code that comes as a demo on the Gemma board, and what you got here is the touch library, digital and analog controllers, I guess stuff for the board itself, keyboard library, and key code so that you can send stuff from this as a keyboard. Remember we mentioned it works that way. Plus a dot star LED control library and a time library. If you want to add extra libraries to this so that you can use them in your code, you just add them in a folder as Python files on the little USB disk that it shows up as. It's amazing! That's all you have to do. You don't have to like install really, you just drag and drop and then put the, you know, the import statement in your code. Alright, so then we have we're talking about, okay, here's the dot star LED, this is what it looks like, it's an APA 102, we've got a brightness on 1/10 brightness, or 1/5 brightness I guess, because these things can go really bright, and you don't always want to blind yourself, and also you might want to save a little bit of energy so you can turn down the brightness. You've got the built-in red LED that is responding to your touch. LED direction, I guess that's just telling it it's an output instead of an input. Pin, okay. You have an analog output on pin A0, and we'll take a look at what that's doing in a second. It's pretty weird and interesting. And then the analog in input on A1, which is, oh wait. Oh no. Analog input on A1. Oh, that's reading. Okay, yeah. And then you have capacitive touch on A2, which is the same as D0. Okay, yeah. Then you can do start the keyboard, and we've named it KBD in the demo code. You're reading the analog voltage on that one pin. Okay. we'll take a look at this color wheel code. So this is the code for the dot star. And the way they do it is kind of cool. So you can see that it's just sort of fading in a rainbow effect, right? And the way that they do that is having a variable called pause, which goes between 0 and 255 and then starts again. And it starts off, and then for the first third of the wheel, so 0 to 255, 1/3 of that is 85, and 2/3 of that is 170. So for the first third of this, we are fading up the red color and down the green color from full brightness. So red is fading brighter, green is fading from full brightness down, and then blue is totally off. Next up, now that red is at full brightness and green is at 0, you start fading red down and blue up from 0. And then finally in the last third, red is already, it's just been faded down to 0, so that stays off. You start fading green back up from 0 again, and start fading blue down from full brightness. And at the end of that cycle, then blue is at 0 again, red is still at 0, you start fading that up, and green is at full brightness, you start fading that down, etc. So it makes a nice, pretty smooth color wheel through orange and magenta and cyan, which is pretty cool. So in the main loop, I equals 0 is what you start with, and this is basically your little sort of clock for the entire circuit. So not only are you fading this color wheel over the course of your cycle, but you're also fading through an analog input value on analog pin 0, which is cool, and we're going to take a look at that with the multimeter. So that's what we were doing before with the analog output on A0. Remember that? That's coming back here. You are setting analog output to 0 to 3.3 volts in increments. So it just goes from 0 to 3.3, and then 0 to 3.3, and then 0 to 3.3. Yeah, it's really interesting. And then also you are printing the input voltage on pin A1 to the console. We'll come back to that in a second. And then also you are doing this, reading the touch value on the touch pin. And then if it is, if it's touched, then you print that also to the console. And then also you set the LED's on-off value to whether or not the pin is touched. So those two are the same. If the pin is touched, the LED is on. And then you have this clock, the I equals I plus 1, modulo 256. That means each time it goes through, it's going to add 1 to I until it hits 256, and then it's going to reset to 0 and come back up again. And that's how you get your whole little cycle. There's also a README embedded in here, which has a link to the product page and a little bit more about what this demo code is doing. Pretty cool. So, how do you get console feedback from this thing? It's pretty cool. It's not totally intuitive, but it's quite easy. Okay, so on a Mac, I should stipulate, I don't know how to do this on Windows. Probably it's pretty simple as well. The way that I do this is in the terminal, I say ls-dev-star. And what that does is gives me a list of a bunch of different stuff that's connected to ports on my computer. ls means show, and then this is just like a directory. And so then I scroll all the way up. And what I'm looking for is, I can use this one, I think, dev/cu.usb modem, blah, 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 blah. Or what I was using before was dev/tty USB, and I know that that one works, so let's go with that. So what I'm going to do with that is open up a screen session, which basically allows me to see the communications coming from this and talk to it, if that were a thing I wanted to do. So in order to do that, I say, I'm just going to open up another little window here. Oh no, it's tiny! Okay, let's stick in the big one. So screen/dev/ and I can either paste what I just copied for that port, or I can use tab complete. So tty dot and then just I think it's USB modem. Yeah, there we go. I'm really bad at remembering this stuff, so tab complete is like my friend, and there's like a 5-digit number on the end of that. I don't know what's going on there. Ooh! I lied. Maybe it's the CU mode. Wait, before it worked on TTY. Well, let's see if we can get you the cu.usb modem. Live demos. Oh no, I can't find it. Well, this is very surprising. Actually, it just worked like 5 minutes ago. I'm probably doing something foolish that is not occurring to me right now because I'm trying to do a live stream. But I'll come back with an actual full Hackster project on getting started with these guys, which will include this stuff on the terminal and whatnot. Ooh. Yeah. In the meantime, everything is falling to pieces. Okay, in the meantime, let's take a look at this multimeter thing with the voltage coming off of that analog pin. So this is showing in millivolts right now. And I'm gonna stick my probes in here. Analog 0. And here you can see that it's going up from, I should move this so you can see when it's millivolts and when it's total, like regular volts. But we have a little bit of glare. Okay, there we go. So right now it's just sort of like a random tiny amount of voltage that it's reading, right? I put these connectors on and suddenly we are going from 0 through the 1s and the 2 points and then up to 3.3. And then when it loops around, it looks a little weird and spazzy for a moment, and that's just because it's showing millivolts. It switches to millivolts because that's a better thing to display when it's sub 1 volt. And then it goes back to showing 1 point whatever, 2 point whatever, 3 point whatever, and then back to millivolts. So that's what's going on the analog 0 pin. As we mentioned, that's just going from, it follows the loop and goes in increments from 0 to 3.3 volts. So they've got all kinds of cool stuff built in here, and what I love about the fact that this ships with demo code is that it gives you instantly a great way to start interacting with your board. One of the key things about Hackster that the reasons for the community to exist is that the easiest way to get started with new tech is to see an example and start tweaking it to do what you want, just like with software. And so they give you a lot of really solid ground to start off with that. As mentioned, yeah, I'm going to pay it forward by creating a Hackster project to give you an intro. You can also check out Adafruit's, whatever suits your fancy. But yeah, we'll have some cool information on that up for you soon. Thanks for watching. This has been MCU Monday. I'm Alex Glow with Hackster.io. And yeah, leave us a note in the comments if you want to learn more, and we'll put the links up to this product page as well as well as the information for getting started in just a minute here. Thanks for watching. Have an awesome Monday.